to tell you the most important things you need to know about hydrogen. And one of the things is just thinking about big picture, and I love this picture from the Department of Energy in the United States, is that it shows where hydrogen can fit in. Hydrogen can fit in as a precursor to making synthetic fuels. It can be used for fertilizers. It can be used and burned in place of things like natural gas. So it can be used as heating services, especially high heating services. It can be used as energy storage for electricity because we can use hydrogen in fuel cells to make electricity. And we can use it in transportation through fuel cells as well. So there's lots of different places hydrogen could really fit in. So what I'm hoping to give you a sense of today is what do we mean when we're talking about hydrogen? Why is it part of the decarbonization conversations that are going on? And what is the status? What's happening with hydrogen? So hydrogen is our simplest atom, remembering our chemical table, our periodic table here. It is one proton and one electron. It's colorless and odorless. When we're talking about hydrogen, it's not just the atom. It exists as H2, two hydrogen atoms together that are bonded. It is highly combustible. So in a pretty low oxygen environment, hydrogen will combust. It will react with oxygen. So oftentimes part of the challenge with working with hydrogen is making sure it's not leaking into the atmosphere because with the oxygen in the air, it will react and burn. And that flame is also colorless and odorless. So it often can be hard to find that flame. So when you're thinking about hydrogen and working with hydrogen, these are some of the challenges. Other things to think about, because it is that first atom, it's our smallest atom, H2 is also a very small molecule. And so when we're building hydrogen infrastructure, we really have to plan for and build for a very small atom that can leak out of things like a natural gas system. You can't just put it in a natural gas system. You have to worry about leakage. So all of those things are aspects of hydrogen. It is tasteless, it is non-toxic, it's not harmful for us. We don't worry about spilling hydrogen or something like that. Releasing it from a toxicity standpoint, it doesn't harm human health. Hydrogen is an energy carrier, not an energy resource. And so here I'm showing you kind of the map of our energy systems, right? Humans care about energy services. What we have on planet Earth are energy resources. A lot of times we convert an energy resource to an energy currency or an energy carrier or secondary energy in order to utilize that to move the energy to the service that we need. So hydrogen is not an energy resource. It doesn't replace an energy resource. We have to use energy resources to create hydrogen. Right now, we're mostly using fossil fuels, particularly natural gas, but potentially we could use electricity and use nuclear, wind, solar, other forms of electricity to create the hydrogen. But it's not an energy resource itself. It is an energy carrier like electricity. It is thought about for one of the services it could provide is energy storage. We could actually take the hydrogen that we're making and store it maybe underground or something like that. And then when we take the hydrogen back out, we can use a fuel cell. So we can use an electrolyzer to make the hydrogen. We can use a fuel cell to make that back into electricity. So it can be used as an energy storage medium. In theory, it is not being used as an energy storage medium today. I put this little question mark down here because one thing that people are talking about for hydrogen, even though it's not an energy resource, is there geologic hydrogen available on our planet? Could we actually drill for hydrogen? There are companies and startups that are looking for pockets of hydrogen in the subsurface. And in that case, then yes, that would be an energy resource. This is not being done commercially. It is still very much in the early stages. Hydrogen is really energy dense by weight, but very low by volume. It is a gas. And so when we're thinking about its energy content, we really have to compress it or liquefy it or something else to really get that volumetric energy density higher if we're going to use it in something like transportation. So this is where hydrogen has a challenge of competing with things like batteries or diesel or gasoline because it's very low energy density by volume. But by weight, it is very high energy dense. This is where we're getting a lot of our energy when we're burning things, is from those hydrogen bonds. You often hear about the colors of hydrogen. Hydrogen itself is a colorless gas. It is clear. There is no difference when you hear about gray hydrogen, blue hydrogen, green hydrogen in the hydrogen itself. These colors refer to how we're producing the hydrogen. And so there's kind of this rainbow of colors associated with how we're producing the hydrogen. What that color gives you a sense of is the carbon intensity of producing that hydrogen. That's why we have these different distinctions. So gray hydrogen is the most common way we're producing hydrogen. That's steam methane reforming, converting natural gas. We're basically stripping the hydrogen off the natural gas. That releases CO2. So that is a carbon intensive way of producing hydrogen. It's the way we're doing it today. That's our gray hydrogen. We could also produce hydrogen from coal. In theory, that would be brown hydrogen. We could do carbon capture and storage with our gray hydrogen, and that would turn it to blue. So now we have lower CO2 emissions. And then the one that's really talked about a lot is green hydrogen. This would be producing hydrogen from renewable electricity through electrolysis. So basically taking water, running that through an electrolysis system that would then produce the hydrogen, strip it off of the water molecules and produce hydrogen. That one would be zero carbon because you'd be using renewable resources. So that's kind of the landscape of the major ways that we talk about the colors of hydrogen. I mentioned that most of our hydrogen is produced from fossil fuels today, and that's really most. It's almost 100%. There's a very little amount that is produced electricity today, very much early stages. Most of it is that methane reforming. Some of it has a very small percentage has carbon capture. That's really early stages to make that a low carbon hydrogen. And that byproduct wedge is really from oil refineries where they produce hydrogen as a byproduct. Really, hydrogen today is produced by fossil fuels. We can make it from electrocuting water, basically an electrolysis system where we could make green hydrogen or low carbon hydrogen using renewables or nuclear or even just the electricity mix. It is more expensive to do it this way. We are seeing growth in interest in hydrogen production with electrolyzers. So what I'm showing you here is the electrolyzer additions. You really see this big growth in places like the United States and China. It is still very small scale, just like you saw that we're not producing a lot of hydrogen from our electricity system. And part of that is that there isn't enough demand for this decarbonized hydrogen like green hydrogen, and it's much more costly. So until there is really demand for low carbon or zero carbon hydrogen that justifies kind of the difference in price, we're going to see the methane reforming hydrogen really dominate the hydrogen system. What do we use hydrogen for? Well, today primarily we're using it either for oil refining, we use it for upgrading fuels, or we're using it for ammonia production for fertilizer production. So those are kind of the two main things that we're using it for today. There are potential to use it more in things like iron and steel or other industrial processes to decarbonize those processes that are right now using coal or natural gas. But again, until we have a demand for that low carbon hydrogen and those low carbon iron and steel, there isn't a lot of market for this higher cost hydrogen. We can use it in theory for seasonal energy storage. So I mentioned that our hydrogen could be stored and then we could use a fuel cell to turn it back into electricity. The nice thing about hydrogen storage compared to something like battery storage is that you could really store that hydrogen for long periods. So some people think about hydrogen storage as an option for seasonal storage. The reason seasonal storage is beneficial is then we can basically take summer sunshine from our solar and move it into the winter when there is less solar available. So we can make better use of that summer sunshine resource. Others are often thinking about hydrogen for long-range transportation. For short-range transportation, for personal vehicles, electrification is really won out. Hydrogen is not really being looked at as an option there, but hydrogen is still being investigated for kind of mid-range or long-haul transportation options. Again, it is still early stages. I would say these are being investigated, but it is still unclear how these different modes are going to be decarbonized. So that's just a little introduction to hydrogen and where we're at. If you want to see the full lecture on hydrogen, please go to our website and you can see the full conversation about hydrogen. And of course, join our Energy Spotlight if you want a little energy lesson in your inbox each month.